now we would start with our Q&A session. So I would please ask all of the speakers on stage again. So now is the time for all of you to really ask your questions. I would just start with an icebreaker while you're maybe still thinking about it. So as we all know, there are like endless possibilities when it comes to data science of softwares and tools that are typically used. So can you share your favorite ones? What are the ones you're using? We start on that side.
For me, it's the tablet because it remembers me and really I'm able to bring home a better data quality.
Mm-hmm. Okay.
I think for me it's this whole field of deep learning. For me, this is really, because I sometimes have the feeling that this is the game changer for this whole microelectronic topic. Because if I learn somewhere where I have the computer power and transfer it then to a very small and tiny thing, therefore, I really would love that there is a big progress in the next years so that we really can use this. And then we use this with a kind of security. You know, I'm a physicist, there is always a little bit like black and white and nothing in between. And especially for industry topics, I have the feeling that I need to know, is it working or is it not working, and nothing in between. I think these are my favorite topics for the moment.
Okay, thank you.
Well, for me, it's basically design of computer experiments. So the transition from theory, so using my mathematical equations, into computational burdens or implementation. So I think this is,
okay.
Interesting.
Thanks for the insight. Absolutely makes sense to me. So, the audience, does anybody already have a question? Also, of course, for our online community.
So if I'm allowed to ask a question, I have one for Vanessa. So you said you do change detection on point clouds, for example, detecting missing trees. So I would now be interested on how you would align two point clouds that were taken or captured into different points in time. Is it somehow because it's actually a really difficult problem, this point cloud alignment. So is there a strategy?
Yeah, it's always to say how it works, so just calculating minus, it's a really easy approach. But this point cloud merging is one of the biggest issues we really have to deal with it, because now we have a lot of approaches, and most of the time we still do it manually, because these automated things are working fine if you have a bigger approach, but just have those small things, you're most of the time at the moment forced to do it manually. But we really need to get to these algorithms that we can automate this process.
Okay, thanks.
Yeah, please. Thank you, Eva.
Yeah, I may have a question regarding the Silicon Austria lab.
Mm-hmm.
Yeah, I remember that at first, thank you for your great presentation, and I may have this question that I remember that you said industry, semiconductor industry, that they mostly prefer to, store their data in the traditional storages. One thing that is not makes sense to me is that right now there are so much, traditional storages are so much cost effective, and also the maintenance is have a lot of challenges. Why they don't want to go, to move out from traditional things to like clouds?
I think not traditional, it's not about cloud or not. For me, the topic is more in the direction of the predictive maintenance. If you have a tool in your fab, you have a tool supplier. This tool supplier is very interested in the data when the device is running. But it's also a little bit difficult because a tool supplier has not only one customer. So the big tool supplier working for everybody in the branch. And then there is really no chance to give them access. A tool supplier wants to have this access to see what is going good, what is going wrong, what is the processes they run. For example, I know a topic where I know that one of the big ones has a process on a certain tool where the tool supplier does not know why they reach this accuracy. And it's nothing that is just by mistake or it just happens, because it's really, they manage to change the process, a standard process, to a way that improves the quality of the tool a lot. So there is an interest in both directions. But on the other side, this letting the tool supplier look inside the fab will have a big advantage, because they have a lot of experience of maintenance. So they will know when a certain part should be changed. They will know when is the right time to order. And this, when we think about the big supply chains in the moment that collapses, and we know also in the supermarket there are things that are not available. This is completely strange for us. When we think about semiconductor manufacturing, it's not just the Ukrainian steel that is missing. There are many parts, especially these very high performance polymer parts. There is really difficulties with the supply chain. So it would be good if we know in advance for 4 months, 5 months that this special tool in Malaysia will need this part. So it's really a trade-off, what is the right way of doing it. In the moment, at least I don't know any semiconductor fab that gives out data. And so when we work together with the tool supplier in our clean room, they are really interested to get this data. For us it's easy, because for us it's always an advantage to have the equipment supplier as partner in the value chain. So it's not so difficult. But sure, we know they have certain access also to our process manufacturing changes. But we try always, we call it equipment partnerships, and we really try to combine it. This means that the equipment partner pays also us in research, and therefore he gets certain things about the processes. And there it's really a symbiosis to work. But for the semiconductor industry, it's not so easy. And I don't know if it will change so quickly.
Yeah, I understand. Thank you.
Thank you.
Are there more questions? I think.
So as you know, one aim or one goal of Women in Data Science is also to encourage the networking between female data scientists. And when I followed your talks, Iris and Vanessa, I was thinking, Iris, you're modeling air pollution along a specific valley, and Vanessa is monitoring the storage potential of carbon dioxide. Why not work together? And no, that's bringing in another factor variable into your second order partial differential equation. But you're a mathematician, so nothing is too tough for you. And also this pollution variable could also have an impact on carbon dioxide storage. So really what we would love to see if we could get you on stage next year again. Together. So, can you imagine working together?
For sure.
After I fix the problem with the deposition, yes.
Yeah. So I think it's a really nice idea, because I'm always the ecologist, so I have a lot of project partners, because I really like to measure the forest also, so not just calculating indicators. So I really need such project partners who are sitting from the computer and thinking about all those models.
Well, I'm here.
So, any more questions? We have one over here.
Hello, Micha von Lamb Research. I had a question regarding the deposition and dispersion modeling. I would be interested in how is it about the scaling of that models. So they're used in a really large spatial scale, but are they also used in a, like, for example, having a 3D printer as your source and the room, and then there these particles get dispersed?
I mean, it totally depends how long you want to run this model. I mean, in our Alpine region, we have this chimney located there, and we also separate it into, okay, we take a shorter version of it. So we look into a shorter area, because we know how much pollution is actually right around the chimney. But we also want to know if the dispersion is just far away. So it just depends on that, what you want to have, but yes.
I have perhaps a comment also to your collaboration. I understand your way through the forest, and I think really this combination of the drone picture, when thinking about virtual reality glasses, this could be a very interesting one. And I think especially the No Center, and also I think Eva is going in this direction with this project, where I think this combination of going through the forest and the above could really make a difference, because also there you will find certain, with data science you will have certain possibility to find out which tree is which. And I think this might be also an interesting connection.
Yeah, it is. So
and at least then you know what was my view last year, or the last time I went there.
So it's really depressing if you're sitting at the computer having a look on just a picture and think, oh yeah, and how was the tree on the other way? Okay, I cannot imagine. But now with those photogrammetry, I just hit on my computer and say, oh yeah, let's take her out. Okay, yeah, now I know again. Because sometimes it's also important that you remember what you saw out there to make your results, because it's a forest, it's always so many, so I think it's in every environment, but the forest, there is a biodiversity, then you have those abiotic factors, then all the biotics, so we always write down, and on the monitoring, we sometimes have several hundreds of fields we filled out, and to make later on an analysis and say, yeah, it looks like this and it was that, it's...
Yeah. But these virtual reality glasses, especially for maintenance in fabs, they're really a huge progress have been done. And if you see beside your reality the virtual pictures, I think this might also help in your field.
Yeah, we also think so.
Olivia, please, finally.
Yeah, I tried again. Yeah, so thanks, just a comment to Vanessa, thanks for highlighting how difficult it is to get data and to get good quality data and to get it into a database. This is really something we need to focus more on. But my question goes to Iris. So you said that you had 13 sensors, and it's also related to what Christina told us. So you do some virtual sensing, actually. So you have 13 positions. And then you just said in a side sentence, yes, and we do some averaging around the sensor. I would be really interested how you do this in a mountain area. Where say, okay, how do you define the average? What are your borders? So what are the conditions? Which data points, how close must be another data point or another point that you predict in order to do this? Or do you do just, okay, I have a round area around it and everything has the same mean value? How do you do that?
I mean, I was quiet about the fact that the inverse distance weighting method is not the best one. So it's exactly that problem you told currently, what we have and what we forced. So what we do is that we say, okay, we have flat terrain, and then we have this measurement station, and then we downscale them. So actually we don't add up the topography in the inverse distance weighting method. But this is a currently project I will start in October, because the wind field is basically an Bayesian inverse problem. So we can regenerate this wind field using Navier-Stokes equation, and that would be better than to using this inverse distance weighting method. That's true, yes. So, yeah, hopefully.
If you need help there at the Knaster Lab, we have really a specialist on these Navier-Stokes topics. If you're interested.
Well, that's perfect.
So, and I think he's willing to give hints. He's also working at the FH.
Okay.
Jarek Kaczynski is really specialist on this topic, yes. So it's crazy long line equations.
So a lot of collaborations are starting here today, that's great. So are there any more questions? Yeah.
Actually, I have a mic, but I don't know. Just use it. Just use it. How do I switch it? No, you don't have to switch it on. It's working?
Yes.
See if I'm doing everything right. Okay.
First, thanks from my side and also from the audience online for the interesting talks. I just want to forward the virtual applause to the three of you. Actually, I have a question to Vanessa, because you talked about that the way how you collect the data changed in the last years, how you got more technical support for that, you use lasers, you use drones, and how this adds more insight into your data. But I'm also working at Vienna in the production automation. So I have the question that do you think, or maybe even fear, that the way how you collect data will change so much in the next years that the going into the forest and collecting data, it's getting less and less. So because I got the impression that you really like doing that. So do you fear that this is somehow that you could someday do without manual data collection, or do you think that this will stay to a certain extent?
We had a project, and the goal of the project was that a drone is going through the forest automated, so no human needed. But at the end it was really tricky, so it worked, but it's tricky. And we stay out there and then say, yeah, it's difficult. And as an ecologist, it was like, oh man, it's an open forest, no dance on the story, so come on. So it's not always just easy. So also if those things are working, you need the person out there. So I was flying with the drone. She lost GPS and then she went down. And I was like, oh, what happened? So I think it will take a bit of time that we are at this stage where we say, yeah, no, we have those good laser scanning data sets, so we see everything. But at the end, we are not able to see, I think, because there are pictures me hanging over the tree because I had to look on the regeneration underwards. So if it is a living or a dead tree, and this you cannot do automated. And also for those 200 different 2,000, species in the vegetation we have. So I really believe that there are algorithms, that there are machine learning and AI and so on, which really can help us to get a glimpse on what different ecosystems do we have. But to really do this without human making pictures and have a single grass separated from each other, I think it's tricky, and we need a specialist also in future.
Okay, we would have time for one last small question. So is there anyone left? Yes, please.
Hello, everyone. Thank you very much for hosting us with nice speeches. I would just like to ask you, do you feel that you have a supportive community when it comes down to data problems in your work? Do you feel like you have enough support in solving the problems?
To whom was the question? To everyone, okay.
Perhaps I can start. I think there are many algorithms there, and there is a certain support from basic science to start. But I think there is much room, because really speeding up energy saving topics and what data are needed, I think there is many things to be done. And so really I believe it's a field where basic research is crucial, because one step is this implementation, when I bring it to as I said, a small chip or something like this, or do it in the edge, or do it in the cloud, or wherever. But really this algorithm behind is a crucial thing. And having really the power to sort out quickly good data bad data and data who have failures or something like this. This is really something that is needed in the future. And therefore, it's one of the fields where I believe the data amounts are increasing and we need to do something with it. And in the last year, I had really the feeling that also the industry changes their view on the data. Because for some years, when I started the first projects in this field, I had always a feeling, we are measuring, we are on the safe side. And we are very future-oriented because we are measuring. But this second step, what to do with the data when we have measured, this is now coming. And it's really the velocity of the algorithm that is crucial, and what hardware do I need to make it possible. Because many of the things are, if I think about your equation and the simulation there, I know it's not done on something that I would like to have in the end when I integrate it in my products. So I think plenty of room for all of you and for many young students to work on the topic.
There is, certainly.
I think I just really agree to that. I mean, in my field, so for dispersion modeling, so they want to share data. They want to share the coding. So what I've done is actually to build up from zero. And that's actually, or is a major problem. I think sharing the code, sharing the data, sharing the experiments, and hopefully that will get better in the future. Hopefully get better fast during my PhD, that would be amazing. But I think that should be grow a little bit more. So sharing data, sharing the codes.
Yeah, this makes us topic.
Yeah.
This is one of the crucial points.
I totally agree. So we collect a lot of data, we like to store them, and at the end, some nice reports we also have, but also this community of nature conservation, we really need help. So we need someone who is able to process the data, to really have nice algorithms so that we get results out of that. So I have the feeling that, or maybe also because I have really nice project partners, so that we get the help we really need. And we at the UNESCO-Chair now try to also make a platform that all those things we found out measuring something, we document it somewhere, because also in this nature conservation group, it's important that we share everything we found out, because if we are at the point now, so you're talking to a national park and they say, yeah, now we are starting using drones. Then you are out there and they show you how they fly, and then the drone is not getting up because there was a fence somewhere in the cloud. And so it's really important to share the knowledge we get all together, so that it's also coming back to the base of nature conservation, so that we learn from each other, that we learn from those interdisciplinary approach and spread it also to the community.
Great, thank you. So I think, I think it's time to stop with the Q&A session. So thanks to all of you for the interesting questions, and also, of course, a big, big thank you again to all of the speakers. It was really great that you've been here and that you shared all your work with us. And of course, we also have a small present for you.
Thank you so much. Thank you.